start. So hello, welcome to session 3. This session is intended to answer sort of a problem that I've certainly encountered as I've tried to understand glycans, and that's, where's the glycan? How do I find a way to refer to the glycan that I care about? It's quite difficult, and I'll spend a little bit of time trying to help you understand why it's hard, and then what we're doing with Glygen to try and help you find the glycans that you are interested in. My name is Nathan Edwards, and I think Will York is on the call too. We are part of the Glygen team, and particularly the GNOME project is something, and the motif project is something that I've been leading for the Glygen effort. All right, so here's what I'm hoping to talk about. I'll try and introduce the problem. I'm going to talk about various strategies for finding glycans with particular structural properties, including motifs, glycoenzymes, the idea of related glycans and subsumption, and then various other ways of looking for glycans in the Glygen database. So here is a pretty common problem trying to go between the sorts of representations. Oh, and I encourage you to ask questions in the chat. I have the chat up, and I'll try and watch it and see whether or not there's something I can respond to as we go. So in the top right is a figure that we're quite familiar with. I guess this is a CFG format figure, and it's got all of its linkages specified. It turns out that this one has been registered at Glytucan, and it has a very specific Glytucan accession. It also appears in PubChem, and it has a GlycomeDB ID. But as informaticians, we're probably working with something like the IUPAC string below, or probably more likely either the works or the glycoCT sequence below. These are really very complicated and cryptic ways of exactly describing the structure that you see on the top right. And there's no way that anybody ever types this stuff, right? So these are not the ways that we talk and we discuss our glycans, but they are the ways that we need to describe them. But often we actually don't know all the things about the glycan structure that we would like to know. We may not know its root anomeric configuration. We may not know the linkages on the two arms. And in fact, it's actually really important that Glytucan can give us a different accession for the version of the glycan structure in which we don't know that information. So this Glytucan accession is different. It's also found in Unicard KB with a specific accession. It's not in PubChem because PubChem cannot represent something with this degree of unknown information about the structure. And down below, we have these glycan sequences, which seek to exactly characterize the extent to which we do, and we don't know particular information about the structure. The trouble is that we don't walk around with these sequences in our back pocket, and we certainly don't walk around with these Glytucan accessions in our back pocket. What we often walk around with is these compositions, these shorthands that allow us to discuss the glycans we mean without having to describe them in that much detail, even if we intuitively understand this information in our head. If we're talking about monosaccharide compositions, we often talk in terms of hex-NACs and hex. So here's a composition, 4-hex-NACs, 5-hex, 2-NUACs. So often see this written 4520. That has a very specific Glytucan accession, which represents that degree of knowledge about the glycan structure. You can see above that we have a composition in which the individual monosaccharides are stated with their stereochemistry. So we know the number of mannoses and gals, we know that they're 4 glycnacs, and so on. In some cases, some search engines will report fucoses, others will report dehexes, and they have different Glytucan accessions too. The problem is that finding Glytucan accessions is difficult. We need the accessions if we're going to put it in the database and attach all the information to it. But this isn't something that we carry around and that is easy to find. How can we find ways to look things up so that we can find the glycan accessions that go with the structure that's in our heads. So I'm going to talk about a variety of strategies we can use in order to find glycans by their structural properties. I'm going to start with glycan motifs. In this case, or in the infrastructures that we're using here, a glycan motif is a small substructure, a small glycan substructure that is designed to match at the reducing end of the glycan, or in some cases, anywhere on the glycan. They are often named to provide some semantic information, either its function or a classification or some other piece of information, but it's a pretty weak degree of semantic information. These aligned motifs are searchable in GlyGen. Our current motif set is glytucan based, but we will be moving to a GlyGen curated motif set soon. And the intention is that this will be a richer, more carefully curated motif set. We can also use the glycomotif site in order to explore these glycans and figure out which ones are the ones we're interested in. I'm going to go to the GlyGen site. And in order to look for our motif, I'm just going to type one that I know is here into the search bar. And the search goes on, and I did a global search. So I end up on this page where I see the hits for the string Lewis Y in various categories. I'm mostly interested in this motif category. This is where Lewis Y matched a motif that has been aligned to glycan structures. So if we look down this list, we can see that each of these structures has the characteristic Lewis Y structure on it, the gal connected to the glycnac with the two fucoses on it. I'm going to scroll down to a specific one. We're now on the glycan detail page, and I want to show you that these motifs are also listed on each of the glycan detail pages. So here is the set of glycan motifs which align to this particular structure. You can see that Lewis Y is down here as expected because that's how we got here, but also a number of the other motifs are here too. We've got the core motif, which indicates that it's complex and glycan. We've got the blood group A motif, and so on and so on. If we click on the motif itself, we get taken to a new view, a motif details view, which allows us to look at all of the structures which align to this, which this motif aligns to. This is going to be very similar to the list that we saw initially because the search term that we used matches exactly one glycan motif. But if we, for whatever reason, ended up on a page and we wanted a very specific list of structures that matched a particular motif, we could get that by looking at the motif page. Now, it's all very well and good that I know that there's a motif called Lewis Y. So let's go back and look at the glycan motifs that are available to us. One of the ways that we can do that in the GlyGen site is to go to the advanced search, scroll down to the glycan motif text box, and start typing. If we type sphing, for example, we get text matches to the sphingolipid motifs. If we type Lewis, we get matches to the Lewis motifs. We get the first 5, which is unfortunate because Lewis Y is the 6th match to the word Lewis, but that's just how it goes. We could even type group in order to find the blood group motifs, which are in the glytucan motif set. Now, all of this is well and good if you know some names of some glycans or you have some ideas about what you should search for, but it's kind of hard to know what they are and how you're going to look for them. So to help with that, where is it? To help with that, we have developed this glycomotif site, which collects and aggregates glycomotifs from many different sources. including glytucan, unicarb KB, glycoepitope, a collection from the CCRC, and so on. And this is the environment in which we are collecting the motifs that we will be soon pushing into Glygen. Let me go to that site. So here is the glycomotif site. I'm going to show you the glytucan motifs. We have a richer set here in the Glygen motifs, but since the glytucan motifs are currently the ones that are integrated with Glygen, I will show you those. So here we have a table of all of the glytucan motifs, including their names and their structures, the cartoons indicating their structures. We can search for Lewis Y to find that structure, and we can see that here is the motif that we saw earlier. This gives us basic information about this motif, including its sequence, and an indication of all of the different entries in other glycomotif collections which have the same underlying motif structure. I want to point out the GGM prefix, which indicates a Glygen motif. GTC indicates a glytucan motif. And this GM prefix represents the union of all of the collections, or the all motif collection. So if I click on this, you can see the aggregation of all of the different names that this particular structure has been given by some collection in the database, even some which are probably not correct. This is how we're able to compare the different names that different groups have given this particular substructure in order to understand and curate which of them might be correct. It also allows us to look at the relationships of different glycan structures in the database. For example, here is the Lewis Y motif structure from glytucan, and you can see in this arrangement that it's related to a structure in which there is no root anima specified, no reducing end anima specified, which allows this version of the motif to match more things. We can also see that in the same topology cluster, but distinct from it, is a version of this motif in which the first fucose is an alpha-4 linkage instead of alpha-3 linkage. So this particular structure, this motif, is different than the other one. And if we go there, we can see that its name is Lewis B. Perhaps these two related structures are the source of those potentially mistaken names from some of the collections. It's by looking at all of the relationships here that we get an opportunity to try and understand how these names and these motif structures are related to one another. The other thing that you can find here is a navigator which helps you see how different structures are related by the addition and the subtraction of monosaccharides from the motif definition. In each case, we are either adding a monosaccharide to the left or taking it from the non-reducing end. Below this, we have a similar thing where we're removing or adding a monosaccharide to the reducing end. This allows us to look at all of the different motifs in this collection, all 600 odd of them, and try and get an understanding of how they're related to each other. Okay, I'm going to pause for a second and see if I have any questions about glycomotifs. All right, moving on. So one of the ways in which we use glycomotifs is as a way of doing classifications. So we like to use these classifications like N-link complex, N-links high manos, O-link core 1, and so on. Now we have motifs that allow us to recognize the reducing ends of these glycan structures, but by themselves they don't do enough to correctly classify our structures within the sorts of semantic classification terms that we're used to. We define these classification motifs. We have a table of them at the glycomotif area, and you can see that we have motifs here for N-glycans and motifs here for O-glycans, including O-manos and O-fucose. I want to show you an example of how the high mannose motif can match lots of things which we would not normally think of as high mannose when we use it to search in GlyGen. So when we do a global search for the words high mannose in GlyGen, we're going to match a few things. We're going to match about almost 700 structures where we're matching on the motif field. But we only match about 250 things when we are matching on the subtype field. Let me show you what this means. So if you look at the structures which match high mannose as a motif, you can see that there's a number of things in here that we would not consider to be high mannose. Why? Well, it's because the motif matched at the core or the reducing end of the glycan, but there's other monosaccharides here, and some of those monosaccharides might take us outside of the realm of what we would consider high mannose. So we are developing a set of heuristics to filter out the false positives that we get from motif matches in order to do a better job of classifying the structures. So if we look in the subtype, then you can see that we have a much better set of high mannose glycans to look at. You can, similar to the motifs, you can find these type and subtype classifications in the advanced search. If you go to glycan type and select N-glycan, you'll be given the opportunity to select a subtype, hybrid complex, posi-mannose, and high mannose. Similarly, if you select O-glycan, you'll have some other options to select. This is an area of active work. We are working hard to try and make these classifications as rich and as accurate as possible. So, if you have insight or you hit structures which you thought should be classified in a certain way based on common usage and they are not, please let us know, or vice versa, if you find things that you think have bad classification labels. This is a very heuristic, sort of semantic process, and it takes some time to get it right. But we are working to make those semantic terms as useful as possible. All right, so that's all I'll say about classification for the moment. I'll pause for a second to see if anybody wants to ask questions in the chat. All right, so the next structural property I'd like to talk about is this idea of glycoenzymes. GlyGen has integrated in it the set of all glycosyl transferases that attach a specific monosaccharide with specific linkage in specific contexts. And these are associated with the structures that they are related to. This is based on Will York's canonical glycotree infrastructure, and it allows us, if we have some prior knowledge about a specific enzyme being related to our glycan of interest, to find structures which could have been built using that enzyme. So an example of that search is beta-4 GalNAc transferase 3. This is a specific gene name. We can type that into the global search and discover that we get a hit for 90 glycan structures in the enzyme field. Looking at the enzyme field, you can see that the structures we see here all have a beta-4 GalNAc on the end of one of the complex N-glycan arms. This is the job of the enzyme, and so we have been able to find and pull out each of the structures which have that specific linkage of that specific monosaccharide. It might take a little bit of prior knowledge in order to know what those enzymes are, but if you already have that information, this is a really useful way of doing finding structures which respect that enzyme. All right, so All of that's well and good. I've shown you a few different ways of looking for structures which have a specific structural element or a motif element. But in fact, when we do this, what we get is a big long list of glycan structures, some of which might be sort of relevant, but it's too hard to look at each one, and it's hard to spot those specific linkage details. We need a way to say this structure is kind of like what I'm interested in, but either the monosaccharide details or the topology or the specific linkages are not quite right. We need to be able to select something close enough and then refine the specific structure to make sure we get exactly the one we need. So I'm going to use the example from the beta-4 GalNAc transferase 3, and I'm going to look at a specific structure here. Where is it? It's this one here. So this happens to be a fully instantiated glycan structure with all of the linkages specified. But supposing we just wanted to investigate what other structures were there, or we wanted to find variants that were sort of like it. So I clicked on the related glycan button, and I ended up in the GNOME subsumption navigator. This is a place where we can look at all of the structures which are related to the structure we started with. In this case, the structure to the top left is missing its reducing in anomeric configuration, whereas the structure on the bottom left it doesn't say where the and it doesn't say very much about the linkage on the arm of this monosaccharide. Suppose we were interested, for example, in discovering whether or not this structure that we started with could be found with alpha anomeric configuration at the reducing end. We double click on the top left glycan and we're taken to a new view in which that glycan is the center. We see to the right, we have our old glycan, but it's the only one that is more specific, the one we have with a missing root or reducing end anomer. So we answered our own question. Our database doesn't have an alpha reducing end anomer for this glycan structure. There are a few other things that I can show you while we're here. If we decide that we want this structure that we're looking at more than the one we started with, we can right-click on it and easily either copy the accession number or jump right back into Glygen. I'm going to use the back button to go back where we started, and I'm going to investigate the more perhaps interesting structure to the bottom left. So if I double click on this more interesting structure, maybe I want to know whether or not this alpha-3 sialic acid could be attached to the GalNAc as well as the Gal we've already seen it attached to. So when we go up a level in subsumption, we're looking at all of the structures below it in which the sialic acid is attached. And we see that in both of them, in one case it's on the 3 arm, and in the other case it's on the 6 arm. But in neither case is it on the GalNAc. So we've just answered our own question. Our database doesn't provide a version of this structure that attaches the sialic acid to the GalNAc. That perhaps is a useful thing, depending on what we're interested in. But what if I'm not even convinced that this alpha-3 should be an alpha-3? Maybe I'm interested in alpha-6. How would I find a version of this structure which had an alpha-6 sialic acid? Well, in that case, I just need to keep going up the sialic, up the tree. I went up another step, and we can see that the information about the alpha-3 is lost. And to the right, we have structures, some of which are alpha-3 and some of which are alpha-6. If I cared about alpha-6, I could then navigate back down the tree to investigate those glycan structures. The other thing that's here is a completely empty linkage information version of the structure. You can see we have question marks for all of the linkage positions, and so consequently we call this a topology. This is a really useful concept, and we use it in a number of places. I'm going to keep, oh, the other thing I need to say here is that the structure in the top left is interesting because instead of saying that we know what the stereochemistry is of these ARM monosaccharides, we're actually saying we don't know whether, we only know whether it's a hex. We don't know whether it's a gal or a mannose or a glucose. Similarly, we don't know whether it's a glycnac or a galnac on the arm. So that's interesting. Maybe we don't even believe this should be a galnac, and we're interested in finding structures which have glycnac in that spot. So let's go back up and see if there are any structures in which this extra arm hexnac is a galnac for this, is a glycnac for this structure, for this topology. So below it, we can see that all of the structures which are consistent with our current topology resolve this hexnac as a galnac. But maybe we don't even believe that this is the correct topology. Let's go up another couple of levels. And then I'm going to use this up button over here on the left, which takes me to a view where I can see all of the topologies related to this particular monosaccharide composition. You can see that in the bottom left, we have a structure which is more like a 3-arm or a 3-antennary complex and glycan with 1 arm on it. And so we can click on that and navigate to more specific versions of that glycan. We can go back to where we are and we can add additional monosaccharides. In this case, I added an extra salicylic acid, and we can click on that in order to navigate to things which are interesting. And we can go down and look at all of the different structures that are down there, resolving the different linkages until we find the structure that we actually care about. But even more than that, we can get into our clipboard from the pop-up menu all of the descendants by subsumption of this topology glycan structure in front of us and take a copy of it. Going back to Glygen then, what I'd really like to do is get a list of all of these and see which of them are attached to proteins. I'm going to go to Advanced Search, and I'm going to paste in all of those glytucan accessions that were put on my clipboard using that pop-up menu and copy descendants. Search glycan. And so now I have a list of the 16 glycans that were descendants of that particular topology. As you scroll down the list, you can see they're all rather similar. In some cases, we have more or less information about how it goes together. And in some cases, the galnac switches arms. But these are all of the possibilities. I can even sort this table based on the number of glycoproteins that these structures are attached to. So there are a number of these are actually annotated as being attached to glycoproteins. And so these become more interesting structures for us to look at. All right. I'm moving pretty fast because I ran out of time in the previous presentation. Does anybody have questions for me in the chat? All right. Okay. I would like to show you another few ways that we can find glycans in Glygen that respect certain structural properties that we know about and we would like to use as a query mechanism. So in particular, again, I'm going to the glycan search and advanced search. So one of the ways that we could search for glycans is, again, by searching for their underivatized molecular weight. You can see that this is termed monoisotopic mass, and we are selecting the option native. So I happen to know this particular mass off the top of my head. 22222 is a biantennary disialylated complex N glycan. You can see that I put in the mass and the mass 1 unit higher. And I do a search, and you can see that I get the glycan structures I need. Here is the native mass, or the underrivetized molecular weight of this glycan, which is how we managed to pull each of these out. Now, again, I don't recommend staring at this list one at a time to try and decide which of these you want. I suggest you go to any of them that look about right and use related glycans to figure out which one has exactly the linkages, either known or unknown, that you actually need for your purpose. We can not only search with respect to underrivetized molecular weight, but we also have permethylated molecular weights in here. The same set of glycan structures, their permethylated molecular weights are about 2,769. And so I can do a search on that basis, and again, hit similar structures. If we're doing work with detached glycans, we might care about permethylated molecular weights rather than underrivetized molecular weights. Yet another way that we can use knowledge of the glycan structure to find glycans, again, under the glycan search, is this composition search. In this case, I'm going to show you how you would ask for a specific composition that you're interested in. First, you say, I only want to see glycans which have just the monosaccharides I specify. And I'm going to then specify 5 hexoses, 4 hexnacs, and 2 nuacs. And again, I end up with a similar set of N-glycans, although depending on how it goes, you might find that there are other things here. Since we are, for example, this composition at the top, which includes a hexnac residue rather than specifying glycnac for some of these. All right. So that is some glygen techniques. But I've got one more technique to show you in terms of finding glycan structures which have a specific monosaccharide composition. I'm going to go to the GNOME website. You can get there by typing in the URL, or by going via related glycans, or by typing it into Google. And I'm going to show you the interactive browsing GNOME widget. And specifically the GNOME glycan structure browser. This is actually the same thing that you saw just now when we clicked on related glycans, but instead it's showing you a blank slate. We can draw our glycans step by step just by adding monosaccharides. We can add 2 glycnacs at the core, 3 monosaccharides, 2 more glycnacs for the arms. We don't need to do it in order, but I tend to because it makes sense for my head. And we can very rapidly find all of the topologies in the database that correspond to our typical biantennary complex N-glycan that we're used to. And once we have those topologies, we can then investigate the specific structures which might resolve all the way down to a specific fully determined glycan structure. All right, if we don't like this topology, we can go back up and choose a different one. Here is a bisecting. Well, it's not even an N-glycan because it's lost one of its glycnacs. So this isn't so interesting, and so on and so on. It's just a matter of looking through the options that are available. I'm going to pause for a second to see whether anybody has any questions. And I'm going to go back to the GNOME homepage to show you a couple of other GNOME functionalities that you might find useful. All right, since I don't see any questions in the chat, Let's talk about one of the other problems in finding glycans, which is when you have a bunch of mass spec results. Mass spec results generally don't show you structures. They generally don't write out IUPAC accessions. They typically report compositions like hex-NAC, hex, and UAC counts. Some use DHEX, some use Foucault's. How do we find the glytucan accessions that correspond to exactly these compositions in the form that the search engine is providing to us? So I've been working with GNOME in order to make this easier to do. So here's one methodology. We have this concept of semantic names or synonyms in the GNOME ontology that actually list, amongst other things, these specific composition strings. So we need 4 hex-NACs, 5 hexes, and 2 hex. So here we have typed in fact, this is a bionic format composition string, and we can see that it associates exactly with this particular glytucan accession. If we Google GNOME ontb, we start to see some of the benefits of the GNOME ontology being a real ontology and being integrated with the OBO foundry. For free, we get functionality like the following. I'm going to copy and paste this so I don't mess it up. I can paste this string into the search terms at ontb and click directly on the term which corresponds to this. You can see that the GNOME accession is exactly the glytucan accession. You can see the synonyms embedded in the ontology that allow us to find this. And in addition, you can see links in order to jump directly back into the GNOME widgets in order to study what related glycan compositions are related to this one. We can either look for structures which are consistent with this composition, like so, or we can find compositions that are consistent with this composition. In this case, we're looking at subsumption ordering of the glytucan accessions that represent these compositions. So here we have the 542. We can go down the subsumption hierarchy and find those that have more specific versions of the composition. We can even go back and add a DHEX. DHEXs are interesting because sometimes they're shown as DHEXs and sometimes they're shown as Foucault's. And so here you can see that if you're interested in DHEXs, you would use the accession on the left. But if you're interested in calling it a Foucault's, you would use the accession in the middle. Lastly, I want to show you that not only can you get to the composition browser by going through ontb, but you can also get directly to the composition browser. So the composition browser is available here under the interactive tools. We provide both of these browsers, the structure browser and the composition browser. And in each case, you can start with a blank slate. In this case, you're looking at the set of all glytucan accessions. And in the other cases, you are looking at glygen specific sets. All right, it looks like we need to transition back to the main room, and I'm happy to take questions if you have them. I will hope to see those questions on email, I guess, and it looks like we need to go back to the main room. Thanks, everyone.